Okay, let's look at adding and subtracting rational expressions. So when we add and subtract fractions, we're looking for a common denominator. So in this case, we already have a common denominator. So now all we have to do is add the numerators. So we're going to add the two numerators. So we have 4 plus 2, which is 6, and it's over the denominator of 5. I look if I can reduce. I cannot, so I'm done. In this case, we have a denominator of 7 and one of 4, and I need to have them over the same denominator so that I'm able to add them. So I look at 7 and 4 and what they can both go into, and they can both go into 28. So I'm going to say this is over 28, and this is over 28. So 7 was multiplied by 4, so I multiplied 2 by 4 as well, and I get 8. 4 was multiplied by 7, so 3 needs to be multiplied by 7 as well, so we have 21. I add the numerators. I have 29 over 28. 29 and 28 cannot reduce, and so that's the answer. If I look at subtraction, I need the same idea. I need a common denominator, and then I can subtract the numerators. I already have a common denominator of 5, so I can subtract the numerators, and I get 2 over 5. They don't reduce, so we're finished. I have 5 and I have 4. They're not a common denominator, but I can create one. So I can make them both over 20. This was multiplied by 4, so I multiply this one by 4. This was multiplied by 5, so I multiply this by 5. And now I can subtract. So I'm left with minus 7 over 20. It doesn't reduce, and so I'm finished. Let's look at rational expressions now. So I have a denominator of 2 and one of 3. Not a common denominator, so I can create one. They both go into 6, so I'm going to make this over 6 and this over 6. I multiplied this by 3, so I need to multiply the top by 3. I multiplied this by 2, so I multiply the top by 2. So now I can put them over a common denominator, and I'm going to expand the top. So this will give me 3x plus 3 plus 4x minus 10 all over 6. I can add, so I get 7x plus 7 all over 6. And I can factor out a 7. Nothing reduces, so I'm finished. There are no x's on the bottom, so I state simply that there are no restrictions. If I look at this one, I have 3 and I have 15, so I can use 15 as my common denominator. Means this numerator doesn't change. This went from 3 to 15. I multiplied by 5, so I'm going to multiply the top by 5. Now that I have a common denominator, I can expand the top and write it over a single denominator. So I can get 10x plus 25. And now I'm subtracting this expression. I'm actually subtracting everything. So I'm subtracting all of x minus 7. So this actually becomes minus x plus 7 all over 15. I can simplify, so I get 9x plus 32 all over 15. There are no x's on the bottom, and so we say there are no restrictions. Okay, let's look at one where we actually do have some x's on the bottom. So in this case, I have an x minus 1 and an x minus 1 in both. So they have that in common. So when creating a common denominator, we don't need that as an extra thing. I have a 5 and a 2, which will create a 10. So my common denominator will be 10x minus 1 because they both had this, and then this needed to become 10 to create the common denominator. And I'm going to say 10x minus 1. So this already had x minus 1. We went from 5 to 10. We multiplied by 2. So I'm going to multiply the top by 2. This again already had the x minus 1. We went from 2 to 10. So I multiplied it by 5. So I'm going to multiply the top by 5. So now we multiply out the top. And then I'm going to subtract everything that comes. So this would be minus 5 times this, which is minus 5x, and minus 5 times this, which is plus 5, over my common denominator of 10x minus 1. And now I can simplify the top. Over the denominator. Now I need to state restrictions. So there's no restrictions on the 10, 5, or 2 because there's no x attached to them. So the only restriction is on the x minus 1. So I can say that x minus 1 cannot be 0, so x cannot be 1. This next one is a little bit tricky. So it looks like these denominators are the same, but this one is backwards from this one. So what we do is we say, well, this is 4x over x minus 2 minus, we have 2x here. So what I want to do is I want to factor out that minus 1. So if I factor out the minus 1, I'm left with x minus 2. So now these are identical. So now I have 4x over x minus 2. And now I have minus and a minus, which really means this is plus 2x over x minus 2. They have the same common denominator, so I can simply add the numerators. There's my denominator. So now I can say that x minus 2 cannot equal 0, so x cannot equal 2.